Hello and warm welcome everyone. Namaskar. This is your educator Khushwant Fatnani starting off with this session. I have with me students of class 11th and we are together preparing for physics for JEE and NEET. So as you all know, we have been currently dealing with a chapter that is fluids or mechanical properties of fluids. In the previous classes, we have seen how to find out the Torricellian velocity and range and respective time period. In today's class, I have given some questions to the learners. They are dealing with some of these questions ki kaise solve kare, application of what we had seen in the last class, plus one more question. है ना? I'll explain you the question as well as we are discussing it with the learners over here. Chalo, shuru karte hain. Let's begin. So once again, Swarada, is my voice audible? We'll take it with Makesh. Makesh, is my voice audible to you? Good evening, Makesh. Hello, Makesh. Is my voice clearly audible at your end?
Hello, sir.
Yes, Makesh. Is my
Yes.
voice clearly audible at your end?
Yes, sir.
How about you, Aliza? आवाज आ रही है clearly? Can you hear me?
Yes, sir.
Okay, super. So everybody have a look. पहला सवाल जो हमने लिया था, the first question that we had taken, we had a vessel, and from the vessel we had a hole drilled at a height of h/3 from the bottom. We had to calculate v value or the velocity of the water coming out from that hole or the orifice. So what is the Torricelli's theorem? बोलेंगे. Over to you, Aliza. Yes, what is Torricelli's theorem? That v is equal to under root of 2gh. Where what is h here? यहाँ पे h क्या होता है? H is that height of the liquid above the hole or below the hole?
Above the hole.
Above the hole. Good. So suppose let us call that h dash. क्या हम यहाँ से h dash निकाल सकते हैं? Can we calculate
Yes,
h dash
sir.
from here?
H minus h by 3.
Very good. H minus h by 3, which is equal to how much? 2h by 3.
Yes, sir.
So this is the value of the height above that hole. This will determine what will be the velocity of the water coming out or any liquid or fluid that is filled in the vessel. So by this logic, let us try to find out the velocity value. Once again, let us see here. So abhi, Aliza just told that, sir, in order to calculate velocity, we'll use the formula for Torricelli's theorem under root of 2gh, है ना, where h is the height above that orifice, or in the question that we have given, height above the orifice is 2h by 3. When you substitute that, question becomes easier. Abhi substitution mein 2 and 2 squared comes out of the root, ठीक है? And h remains inside, g remains inside, 3 also remains inside, right? So gh by 3, कुछ इस तरह से, right? Achal,
Yes,
okay, Aliza. Achal, are you able to hear us now? Can you hear me clearly?
Yes, sir. Yes, sir.
Good. Acha, after we have calculated v value, abhi let us now try to understand what will be the range. क्या होता है range का formula is 2 times of under root of h into क्या था याद करो, h into h minus capital H, या ये भी कह सकते हैं x minus x into y. x into y मतलब अगर if you have orifice इस तरह से देखना सभी लोग, everybody have a look here. If you have an orifice in a vessel given like this, upward distance from the surface of the fluid is x, lower distance from the base is y. यहाँ से जो पानी बाहर आता है, whatever water comes out, इसका range is given by this formula. क्या ये clear है? Upward height into downward height. Capital ये जो भी x है and this y, इसका multiplication comes over here. So in our question ये x कैसा है? Aliza, we just calculated 2h by 3, और ये y कैसा है? Equal to h.
h by 3.
है ना? h by 3. Yes. अच्छा. By this substitution, range कितना आ जाएगा? 2 times of under root of 2h
H by 3 into 2h by 3.
Very good, super. अच्छा, are we clear on this? We'll take this with Aanchal. ये आया क्या समझ? जल्दी से लिख लो कॉपी में quickly. Is this clear, Aanchal? कि कभी भी
Yes, sir.
range क्या करेंगे? 2 times of under root of distance above the orifice and distance below the orifice. This is a shortcut formula. You all can remember and use this multiple times जब भी these types of questions are asked in the exam. तो ज्यादा समय नहीं लगाना, फटाफट बनाना है इस तरह के क्वेश्चंस को. Therefore the final answer is h by 3 into 2 root 2. ठीक, let's take the next question. अभी question में, yeah, if you all want, we'll do a quick revision. In this question, what were we asked? We were asked two things. You are given that there is a vessel. In the vessel there is water, and you are drilling a hole at a height of h by 3 from the base or at a depth of 2h by 3. है ना? Total length of liquid column or fluid column in this vessel is h. Question में we have applied Torricelli's theorem, which states that V, or velocity of water coming out from the orifice, is under root 2gh, where h or h dash is the height of the water column above that orifice. तो यहाँ पे height above the orifice in our question is 2h by 3. So simply instead of h or h dash, we have substituted 2h by 3 to get the answer as 2 under root of gh by 3. Next step, we were asked range. We know that range is equal to 2 under root of x into y. Sir, what is x? What is y? X is the distance or the height of the water column above the orifice, and y is below the orifice. ऐसा. तो ये easy है. It's easy to remember. So I hope everybody of you are clear. अगर हाँ, जल्दी से raise your hands. Over to you, Aanchal, Aliza, Makesh, everybody watching this session via YouTube. You all can also share your queries. कोई doubt मन में हो, if anything you need to ask, feel free to go ahead and ask the same. Yes, Aanchal, any doubts? Please ask. Yes, over to you, Aanchal.
No doubt, sir.
ठीक है. तो अभी let us move to the next part. ये वाले part में ना, this part is a type of question which you will find in a lot of previous year papers. One minute. हाँ, this one question. ठीक है. अभी let's discuss what this question is all about. Question says that you have a raindrop. ठीक है. Raindrop का mass is m, and this raindrop is coming down in atmosphere from cloud towards the earth's surface. Because the raindrop is coming down, question says that the air around it applies a resistive force on the raindrop. And that resistive force that is applied by the air, this Fr, is in the opposite direction of velocity. It means that if the raindrop is moving down with the velocity v, the resistive force acts in the upward direction. This is one thing. Second, this resistive force depends on velocity. Aanchal, iska meaning kya hua? What is the meaning? The larger is velocity, the larger will be resistive force in magnitude or smaller in magnitude. Over to you, Aanchal. Yes. Hello. Aanchal, is my voice audible? Aanchal, clear ho raha? Hello. Swarada, am I audible? कुछ issue आ रहा है क्या? I think काफी बच्चों को आ रहा है. Is everybody able to clearly hear me?
Yes, sir.
Okay. So, Makesh, tell me one thing. If I write that resistive force over here, the resistive force acting in the upward direction like this, Fr is equal to minus kV or simply kV, whatever. So what does this imply? It implies that if the object's velocity increases in the downward direction, then resistive force will also increase. Am I correct?
Yes, sir.
And since resistive force will increase, it will in turn decrease the velocity, right?
Yes, sir.
And if velocity decreases, resistive force also decreases.
Yes, sir.
And if resistive force decreases, velocity increases.
Yes, sir.
If velocity increases, resistive force increases.
Yes, sir.
If resistive force increases, velocity decreases.
Sir.
So there is a counter effect going on in this question. Are we able to analyze and understand what is happening here? क्या ये बात clear हो रही है? Are we clear with the scenario? No. So this is a counterproductive scenario where velocity is increasing in the downward direction, but that increase in velocity is further increasing the resistive force also, which rather works in decreasing the velocity. तो इस question को calculate कैसे करें? How to get the final velocity if I want that velocity in terms of time? What is Newton's second law of motion? Makesh, F is equal to ma,
Yes,
right? Net force is equal to mass into acceleration. And how will we calculate net force? Tell me, mg minus fr or mg plus fr? Over to you, Makesh. mg minus fr.
MG minus FR, sir.
Okay. And suppose you want to just take the magnitude of fr. Tell me what will be the magnitude of fr here? Yes, Makesh, tell me. It will be equal to kV.
Yes, sir.
Correct. And what is acceleration given as dv by dt or dx by dt?
dV by dt.
dv by dt. So here we'll have a is equal to dv by dt. Correct. Check this out, Makesh.
Yes, sir.
In order to find out velocity, what is the purpose or what is the step that I need to do here? Should I bring velocity wala terms towards one side or should I separate them? Makesh.
Sir, bring velocity on one side, sir.
Okay. So dv upon mg minus kv, right? Makesh, have a look.
Yes, sir.
Now, can we integrate on both sides in order to calculate velocity?
Yes, sir.
Acha, do we remember this? What is the integration of dx upon ax plus b? It is equal to 1 by a log of ax plus b, right? Repeat this. Over to you, Makesh. Yes. Huh.
Integration of dx by ax plus b equal to 1 by a log of ax plus b.
Can we find a similar scenario in this question also? Instead of x here, we have v, right? Instead of x here, we have v.
Yes.
Instead of a, we have minus k here. Dekho, Makesh, can we see that?
Yes, sir.
And instead of b, we have mg. Can we compare these two scenarios that are given in the question?
Yes, sir.
From this scenario, let us integrate 1 with respect to dt. Tell me first on the LHS, what will we get? T by m or m by t?
T by m.
Okay. T by m. And suppose you are being told as this raindrop starts from the atmosphere at t is equal to 0, its velocity is 0. So if it is at rest, your velocity will be 0. So original velocity is 0. So for t is equal to 0, I can put velocity as 0. Am I correct, Makesh?
Yes, sir.
Okay. Finally, at t is equal to t, velocity of this raindrop becomes equal to v. So I can put at t is equal to t, limit of velocity as v. Are we correct until this point, Makesh?
Yes, sir.
Right? Okay. Now let us apply this formula that integration of dx by ax plus b is 1 by a log of ax plus b. So here, this instead of x we have v, substituting same thing. क्या हो जाएगा? You have 1 by a. A क्या है? Minus k or the coefficient of v. यहाँ पे. So 1 upon minus k into log of the entire value. Log of minus kv plus mg. Right? Okay. Super. Then let us substitute the limit on both sides. What are the limits for time, Makesh? 0 to t.
Yes, sir.
What are the limits for velocity?
0 to v, sir.
Excellent. अभी ये तो आ गया. अभी how to get velocity and time का relation independent of log. So do we have a formula for log and exponential conversion? We'll use that shortly. है ना? अच्छा. Can we bring this minus k on the other side after applying the limits? Let us see we can. Okay. So the minus k will go to the other side. ऐसा. T में let's just substitute the limit. So t minus 0 by m. Are we correct in substituting the limits? Can you just check and
Yes,
tell?
sir.
Okay. Instead of v, first we'll put v only. So log of minus kv plus mg. And then let us substitute 0 instead of v. So minus of log 0 plus mg. Heck nahi. Makesh, have a look. Are we clear until this point? Okay. Do we have a property for log? Let us take this with Aliza. What is the property for log, Aliza? Log of a minus log of b is given as how much?
Log A by B.
Very good. Log of a by b. Can you see, Aliza, this property is going to be used in this question very shortly. कर सकते हैं, Aliza?
Yes, sir.
बोलो क्या हो जाएगा? What will be the expression? Minus kv plus mg
Plus mg
divided by
upon
whole divided by
ln
mg.
by mg.
Right? Easy?
Yes, sir.
Okay. Now let us multiply these terms. क्या बनेगा? Minus kt by m. Have a look. Right?
Yes, sir.
अच्छा, okay. Now natural log is log to the base e or log to the base 10?
Log to the base 10.
Natural log is log to the base e.
Okay, sir.
फिर से बोलो, natural log is log to the base.
Log to the base e.
This is log to the base e. Okay. Abhi there is one more formula that we know about. Kya sir? If I write log of a to the base b is equal to c, so we can convert it into non-logarithmic form. कैसे? Or exponential form. B to the power c is equal to a. B to the power c is equal to a. Same logic will be applied here. E to the power minus kt by m is equal to whatever expression holds here. How many of you have understood the expansion? Jaldi se raise your hand quickly. Everybody, I repeat, we know that log ka formula, if log of a to the base b is equal to c, then b ka power c is equal to a. Same logic will be applied here. E to the power minus kt by m is equal to ye wala pura complete expression. Is this clear? If there is any doubt, ask me. So over to you, everybody. Yes, we'll start with Swarada, Makesh. Over to you. Yes. Any doubts? Go for it. Makesh. Swarada, any doubts? Please ask. Yes, Swarada, boliye. Hello, Swarada. हेलो, थोड़ी आवाज कम आ रही है स्वर्दा फॉर सम रीजन, डोंट नो व्हाई, बट मैसेज कर सकते हो चाहो तो स्वर्दा, कोई डाउट हो तो वी कैन क्लियर इट हियर आउट. यस, आंचल आपको क्लियर है?
Yes, sir.
ओके, चलो नेक्स्ट स्टेप, लेट अस डील विद दिस. अभी वी हैव दिस एक्सप्रेशन. यस आंचल, टेल अस द फाइनल नेक्स्ट एक्सप्रेशन. ओवर टू यू आंचल. हाँ, क्या लिखें? Therefore we can write
Power minus kt by m
so let's write minus kv plus mg
by
by
mg
mg is
will be
equal to
e to the power minus kt by m.
e to the power minus kt by m. ठीक है. Can we make v the subject here? Let us try to do that. क्या करेंगे for that? Yes Anshul, over to you.
Take mg in multiplication in the RHS.
Good. So we'll write minus kv plus mg is equal to mg times of e power minus kt by m. अब यहाँ से mg will go to the other side, right?
Yes, sir.
है ना? चलो, let's do that. So we will therefore have
We get
minus kv.
is equal to mg e to the power minus kt by m minus mg.
So we can take mg common, है
We
ना?
take out mg common, so now we'll get,
Like this.
yes, sir, we'll get
Can
minus.
we take minus common from both sides and rather multiply minus on the other side? ऐसा कर सकते हैं?
Yes, sir. So we'll get kv is equal to
हाँ.
mg into 1 minus e to the power kt by m.
Good. So I think Pawan on YouTube is saying hello. Hello Pawan. Okay. Continue. So we can write therefore v is equal to mg by k whole into 1 minus e power minus kt by m. क्या ये clear है? Are we clear on this? Achal. Easy.
Yes, sir.
We have just interchanged the minus ka sign by take, because minus sign minus k is going on the other side and rest remains the same. If everybody is clear on this logic, let me know, and if there is any doubt, go for it. So if this is clear everyone, please raise your hands. I brought all hands down. अगर अब सभी लोगों को ये समझ में आ गया, कृपया करके बतावे. Please tell me, sir, we are clear. Okay, super. If you all want to write this down, I'll again bring this to your site. अभी देखोगे first से what did we do? Let us quickly revise it. ठीक है? Question said that we have a raindrop and this raindrop is coming down. It has a mass mg. It has a mass m. इसका मतलब weight acting on it downwards is mg. Resistive force is acting on this raindrop in the upward direction. This is a question from previous year JEE as well as IIT, and you can expect this in the coming year NEET का paper also. ठीक है? Question says that you need to calculate how is the velocity varying with time. क्या किया? F net is equal to ma. ठीक है? And we know that जिस भी direction में net acceleration is, suppose this ball is going down, तो we can thereby go for ये वाला calculation. Step by step हम करते गए. This resistive force was equal to kV minus kV, but then in magnitude kV. We went further ahead, calculated the logarithmic relation by integration. Formula that we used is integration of dx upon ax plus b is 1 by a log of ax plus b. ये formula use किया. We used this formula and reached our final answer, which is the relationship between velocity and exponential relation. ये जो expression निकल के आ रहा है ना, this expression that we are getting, इसका graph कैसे बनाएं and how to calculate what will be the final velocity and what does the term terminal velocity mean. अभी यहाँ पे we are going to see that. इसीलिए I've named the session as terminal velocity only. इसको समझना सभी लोग. So generally e power x के there are certain types of graph. You will find this in my mathematical tools वाला class. If anybody has forgotten, just go to YouTube में Khushwant Fatnani and in that playlist के अंदर you will see my mathematical tools वाला all the class under 11th standard, class 11. उसमें I have explained different kind of exponential curve. Let us make all the graphs quickly. Exponential curve, quick revision because it is very important. It will be helpful in class 11th or 12th also. Exponential curve, जल्दी से quick revision. Exponential curves. अच्छा, suppose I have the curve y is equal to e power x. ये कैसा curve होगा? Over to you, Makesh. Will this curve be rising or will it be falling? Yes, Makesh. E power x. What do you think? Yes, Makesh. Is it a rising curve or falling curve? That is
Rising, sir.
very good. Suppose I want to calculate its value at x is equal to 0. Tell me what will be the value at x is equal to 0. Y will be e power 0. Anything to the power 0 is
1.
1. Right. So यहाँ पे it means that at on y axis the point will have 0, 1 as the coordinates. Can you check and tell me if this is correct, Makesh? X is 0 and y is 1.
Yes.
As this curve passes the passes the y-axis and it keeps on increasing. ऐसा. Suppose if x is equal to infinity, can I say that y will also be infinity? Makesh, if x is infinity, can I say that y will also be infinity? Because
Yes, sir.
to the power infinity will be a very large number. So infinity comma infinity is a very large value in x and in a very large value in y. So we have joined these two and found the expression. Is this clear to us? Everybody? If yes, raise your hands. If there is any doubt, मुझसे पूछो. Over to you, dear learners. Yes, we have plotted a graph of e power x. This is called exponential curves. ठीक है? Write it down. Okay. Now, Aanchal, let's make the next one with you. क्या करेंगे? Over to you, Aanchal. Suppose I want to draw a graph between y and x, where y this time is e power minus x. अब की बार, this is e power minus x. कैसे करें? Aanchal, this is y and this is x. Tell me, will this be a falling curve or rising curve? सोच के बताओ. Over to you, Aanchal.
Falling curve.
Falling curve. कैसे समझ में आता है? You can differentiate this. dy by dx करो. You will see that the slope is negative. कैसे? Have a look. Tell me what will dy by dx be? It will be equal to
E to the power minus x.
into differentiation of minus x, because it is chain rule, है ना? तो differentiation of minus x will be minus 1.
Yes.
Right? So expression will be minus e power minus x. तो exponentials can never be negative. ये जानते हो कि e के power में कुछ भी रख दो, that value will always be positive. तो ये वाला value is always positive into a negative value. So that means that your final dy by dx will be a negative value. क्या ये clear हो रहा है? Are we clear on this? Yes. इसका मतलब anywhere on the curve, if you draw a tangent, that will always have a negative slope. This is one thing that we are understanding. क्या ये बात अपन को clear है? Over to you, Aanchal. Is this clear to us? मैंने क्या कहा? Exponentials are always positive. चाहे तुम power में कुछ भी ले लो, e power minus 1, e power minus 2, e power 2, e power minus 3. Because if I write e power minus 3, it doesn't mean it is a negative value. It means that it is 1 by e power 3. तो e के power में whatever you take, it will always be a positive value. तो e का power minus x into minus 1 will always be a negative value. How many of you are clear with this logic? Raise your hands quickly. Yes. Slope of this graph is a negative value. इसका मतलब the graph is falling in nature. कितनों को clear? Raise your hands. Doubt, ask me. Over to you. चलो quickly. Makesh, yes, please ask. Clear. Okay. Now, अगर ये clear है, if this logic is understood by all of us, second step, have a look. तो अभी at x is equal to 0, Aanchal, what will be y for this curve? Yes, बोलिए. At x is equal to 0, what will be y? E power minus 0, which is equal to e power 0, which is equal to 1. मतलब ये वाला curve will also start at the same point जहाँ पे this was starting, right? Which is 0, 1. अच्छा, what about x is equal to infinity? Where will the curve go? Y is equal to e power minus infinity. We can write this as 1 by e power infinity. 1 by e power infinity is how much? 1 by infinity, or 1 by infinity को we can write as
0.
0. इसका मतलब this point is going to the curve is going to a point where x is infinity and y is 0. y 0 यहाँ पर है, देखिए, right? Right? और x infinity यहाँ पर है. Am I correct? So we are going to a point over here. ऐसा. Can we understand this properly? देखो. Aanchal, are we able to understand?
आपकी आवाज काफी लो आ रही है.
Is it the same thing with the others also? We'll start from Makesh. Makesh, are you also facing an issue with the voice, or is it clear at your end?
So it is clear, sir.
It is clear. So Aliza, I think we'll ask with others also. Swarada, how about you?
Sir, I think it's my internet.
Okay. Aanchal, आपके end पे, how is the voice?
It's clear, sir.
It's clear. Abibi, is there any issue with the voice? Aliza?
सर मतलब वॉइस आ रही है पर इतनी मतलब काफी लो आ रही है सुनने में. मैं कितनी भी वॉल्यूम बढ़ाऊं फोन की मुझे रीच ही नहीं हो रही है सर.
Is it the same thing with you, Aanchal?
No, sir, आपकी voice clear and loud है.
Okay, so Aliza, can you try refreshing your network, or maybe logging out and logging in, or maybe next session में this will work, because अभी we are ending the session in some time, so.
ओके सर.
ठीक है, अभी मैनेज कर लो. If there is
मैं
any...
अभी कर लेती हूँ नेक्स्ट सेशन.
चलो कर लीजिए. Okay. Even if you want to do it now, you're free to. ठीक है. Okay. तो let us move ahead, everyone. कितने लोगों को ये समझ में आया? So we are joining points 0, 1 and another point which is over here at कहाँ पे x is equal to infinity, y is 0. How many of you understood? देखो, y 0 and x infinity. So we have basically plotted 2 points, x is equal to 0 and x is equal to infinity. Try to see that what is y value at these 2 points and accordingly join these 2 points to get the curve. So देखो, when you will draw a tangent anywhere on this curve, you will always see that the tangent has a negative slope. ठीक है, इस पूरे curve में wherever in this entire curve, if you make a tangent, that tangent will always be negative. Have a look. Always, ever, कभी भी, कहीं पे भी. Have a look. फिर से देखो. If I draw a tangent here, negative slope. If I draw a tangent here, negative slope. पूरे curve के along along the entire curve, slope of the tangent is negative, which is what this equation is speaking. ठीक है. अभी let's make one more curve. ठीक है. We are making one more curve right now. Suppose the curve का equation, now अब ये curve तुम लोग को बनाना है. You have to do it this time. I'll just help you all. So who is ready? Aanchal, are you ready? Try करोगे? Over to you,
Yes,
Aanchal.
sir.
Okay. So let us draw this curve. We'll have x and y axis respectively like the last time. ठीक है? You will have y is equal to, curve is 1 minus e power x or e power minus x. Let's do this. So this is y and this is x. सबसे पहले what were the 3 steps that we did? Aanchal, बोलो, what were the 3 steps? कौन से 3 steps थे? One is slope, the other is x is equal to 0 and infinity. Can we try that here? कोशिश करें. चलो, let's also take another variable y naught which is multiplied by this. हो सकता है this equation will become easy to solve later. तो अब over to you, Aanchal. सबसे पहले let us try to calculate the value of this curve y at x is equal to 0. So when x is 0, tell me how will we get y? हाँ, over to you, Aanchal. Yes.
When x is 0, we'll get y as 0.
1 minus, बोलो नहीं, explain करो
E
everybody.
to the power minus x will be, e to the power 0 will again be 1. So 1 minus 1 into y naught.
Okay, which is
And that
equal
will be
to
0.
1 minus 1 into y naught, which is equal to 0. Right. So this curve is going to start, unlike the other 2 curves. Other 2 curves started somewhere on y-axis. ऐसा ऊपर से it went downwards and here it went in the upward direction. Whereas this ये वाला curve will go in the, देखते हैं, we don't know, but at least it will start at the origin. कितने लोगों को ये first point is clear? Can you all bring your hands down? अगर if this point is clear that this curve that I've drawn here will start from 0, 0, हाँ? Okay. ये ना basic curves है which is important for understanding the curves for terminal velocity. Even in Newton's laws of cooling, this will be of your help. चलो, अब this point is 0, 0. ठीक है? Now that this point is 0, 0, we are also going to see what will be the value at x is equal to infinity. Over to you, Aliza. हाँ, at x is equal to infinity, बोलो, what will be y?
So
Y will be
minus
1
e
minus
to
e power minus
infinity
देखो e power minus infinity
minus infinity
into y naught.
into y naught. So
अच्छा,
1 minus e upon infinity
देखो
into y naught. E upon infinity is 0.
ठीक है, e upon नहीं, 1 upon
1 upon e upon infinity is
upon
0.
नहीं, 1 upon e power infinity. हाँ,
That's okay. 1 upon e power infinity is 0.
is 0. तो either you can write that या e power infinity is infinity, वो लिख दिए. Then 1 by infinity is equal to 0. So 1 minus 0 into y naught. That brings you the value y naught. इसका मतलब at x is equal to infinity, y value is becoming some constant value. क्या कहते हैं? Yes, ऐसे ही हो रहा है. Can we see that?
Yes, sir.
As x advances, जैसे जैसे x बढ़ता है, the y value is approaching to a constant value f naught. तो constant value का curve is this. देखो, y constant. Aanchal, am I correct if I draw that y is equal to y naught curve can be a straight line ऐसा, right? देखो तो Aanchal, can be a
Yes, sir.
straight line. तो as x approaches infinity, it becomes close to this value ऐसा. तो what kind of curve will you find it here? ऐसा वाला. You will find this kind of curve in this question. ऐसा. Is this clear to everybody? कितने लोगों को ये समझा? This point will be, अभी this is, मान लो this point is y is equal to y naught, ये वाला line. So this point will be infinity, y naught. That means for a very large value of x, y is assuming a constant value y naught. ठीक है? This is one thing. How many of you are clear with this logic of the question? If you all are clear, jaldi se raise your hands. Again, 2 points we have taken, and again using these 2 points x is equal to 0 and infinity, we have tried to calculate the value. ये homework है आप लोगों का, one homework. Try to calculate dy by dx for this curve. You will see that is also always positive. Try to calculate dy by dx for this curve. This is your assignment or homework. ठीक है? Try to do this. This will come as positive always. लिखो everybody, write this down into your copies. You will find that prove that dy by dx for this curve will always be positive. Everybody has to submit their homework by tomorrow. अच्छा, are you all clear? कैसे किया हमने? At x is equal to 0, we found y is 0, मतलब this is one point from which the curve passes. Second, at x is equal to infinity, we saw that y value becomes y naught. मतलब for some value of the curve y is equal, like some value of y, ये वाला curve will try to meet this point. मतलब y will try to become constant ultimately. Ultimately, y will try to become constant and equal to y naught. How many of you are clear? Jaldi se, let me know. If this next wala curve is also clear, quickly raise your hands. Yes. If there is any doubt, pucho, ask me. Yes, everybody. Take a screenshot. 5, 4, 3, 2, 1. अभी एक और curve, ठीक है? I'm making you all practice. This practice is very important, ठीक है? अभी suppose there is one more curve that we want to draw. Makesh, are you ready? We'll draw this one with you. You're given y versus x का graph, and y is given as 1 minus e power x, है ना? 1 minus e power x into y naught. चलो, over to you, Makesh. Tell me what will be its value at x is equal to 0. Yes, Makesh, we'll start with you.
Is at the origin, sir.
Okay, let's try to solve it step by step. X is equal to 0. What will be y? 1 minus e power 0 into y naught, right? So 1 minus 1 into y naught, and therefore 0. Are we clear on this, Makesh?
Yes, sir.
Okay. What about the d value for x is equal to infinity? Let's try to do that. X is equal to infinity, we can see that this has become a very, very large value, correct? Very,
Yes,
very
sir.
large value. So again, y will be coming a very, very large number, infinity. But how does the curve reach there? Let's also try to see that. So यहाँ पे we'll have one more expression. An expression क्या है? Expression is, try to find out what is dy by dx. What will be dy by dx? Try and tell us, Makesh. Yes, over to you. Dy by dx will be how much for this one? It will be equal to minus y naught into e power x. This is my take. What is your take, Makesh? Try and confirm if this is correct or there is an error. Makesh.
So why not a constant, sir?
Yes, y naught is a constant. So multiply y naught in the two terms, here also and here also, then differentiate y.
Yours is correct, sir.
Correct? Are everybody of you like clear on this logic? कितने लोगों को समझा? How did I differentiate? If there is any doubt, ask me. Over to you, dear learners. Yes, quickly. Raise your hands if this is clear. कोई doubt हो तो पूछ सकते हो. Over to you, everyone. Yes. Raise your hands if this is clear. If there is any doubt, you all can ask. Clear, everyone? Pakka? Okay. Then this is your assignment. Try to draw this graph. This is again your assignment. Try to draw this graph. ठीक है? Try to tell me how will this graph look like. यहाँ पे ना actually you can write minus infinity because यहाँ पे infinity वाला number is large. 1 minus a very, very large number. So your answer will be y is equal to minus infinity. Now try to think what kind of curve should come over here. This is your homework, everyone. Okay? This is your homework. Next class, do remind me. We'll have a discussion on this. याद कराना, everyone. Okay? Otherwise, you can also find this one on Wolfram. Wolfram is a website where you can find and plot all kinds of curves of this sort. ठीक है? तो Wolfram math पे you all can try this one. It's a website that helps you plot graphs and do many other mathematical functions. ठीक है? चलो, अभी ना, why did I explain so much to you all? यहाँ पे why did we do so much of explanation? We did all of this in order to make our concept stronger and concrete when we are talking about concept of terminal velocity. ये वाला velocity का expression भी देखो, it is in the same form. कितने लोग ये link कर पा रहे हैं? We just saw ये वाला form. देखो everyone, 1 minus e का power minus x is equal to y times of y naught. How many of you are able to link these two forms? देखो तो everyone, if I want to plot velocity versus time का graph, raise your hand जल्दी से. If you all are able to link, अगर link कर पा रहे हो that ये वाला graphs are similar in nature, जल्दी से raise your hands quickly. The only difference is rather than x you just have kt by m in this question. इतना ही difference है, rest everything is same. Check करो everybody. Can you all see that? Aliza, any doubt? Please ask. Yes, Aliza. Okay. Makesh, any doubt? Please ask. Yes, Makesh. Over to you. Clear. Okay. Riyad kar lo, you have to tell this equation. Swarada, we'll go along with you. Yes. Swarada, what is this equation? Read it out loud. V is equal to,
to mg by k. So write
loudly. V is, okay. We can write it again. V is equal to mg by k, 1 minus e power minus kt by m. Up karo, loudly read this.
It's equal to mg by k, 1 minus e raised to minus kt by m.
kt by m. Again we'll try to plot this curve. Let's do that. So here we have the curve of अब की बार v versus t. ठीक है? We'll try to plot this curve of v versus t. Again you have y here, v here and t here. अभी at t is equal to 0 इस कर्व का क्या एक्सप्रेशन होना चाहिए? Let us see. At t is equal to 0. हाँ, over to Swarada. v is equal to mg by k है ना, into 1 minus e power minus 0. देखो, yes. अभी e power 0 is how much? 1 होगा, right?
Yes.
1 minus 1 will give you 0. Therefore, velocity will be 0 at t is equal to 0. That means 0, 0 will be the starting point for this curve. Are we clear on this point, Swarada? Easy? ठीक है. तो यहाँ से this curve will be starting. अच्छा. Now let us talk about time t is equal to infinity. After a very long time, what will happen to velocity? This is important. ठीक है, ध्यान से देखना everybody. Y is equal to mg by k into 1 minus e power minus infinity into anything. Kt by m would not matter, right? So what can we write as? This e power minus infinity can be written as 1 by e power infinity. Dekho, Swarada, am I correct? Check this out. Hello, Swarada. Can you be a little louder? Hello, Swarada.
Yes, sir. Hello.
Now you are clear. So mg by k into 1 minus 1 by infinity. What is 1 by infinity, Swarada? Swarada, what is 1 by infinity? Hello. Okay, I think there is some issue with the microphone. We'll take this with who else is online? Makesh. Yes. Over to you, Makesh. क्या
Zero, sir.
0. ठीक है. So what will be the final answer for velocity?
mg by k, sir.
This will be called terminal velocity. Velocity in such cases wherever resistive forces depends on velocity only. In such cases, after some time, the system attains a constant velocity. Makesh, tell me, if velocity is constant, what will be acceleration? What is acceleration defined as?
The change in velocity, sir.
Change in velocity or dv by dt? What is it defined as?
dv by dt, sir.
Acceleration is always defined as dv by dt. So after infinite time, if velocity is becoming constant and equal to mg by k, can I say that acceleration is becoming 0 at t is equal to infinity?
Yes, sir.
V is becoming equal to mg by k after infinite time. So I can say that acceleration is becoming equal to 0 because acceleration is dv by dt, and if v is becoming constant, acceleration is becoming 0. So if acceleration is becoming 0, what does that imply? Makesh? That net forces acting on the objects are 0 or non-zero? If acceleration is 0, yes. So what were the forces acting? One was resistive force in the upward direction, which we had written as minus kV, right, Makesh? है ना? One was resistive force in the upward direction, which we have written as kV or minus kV, and one was the weight acting downwards. So at t is equal to infinity, which is also called after very long time, you will see that this velocity will become constant. V will become equal to mg by k, as we just saw, and apart from this, we will also see that A is equal to dv by dt, and this will become equal to 0. And therefore, we'll have F net, we know, is equal to mass into acceleration. Acceleration is becoming 0. We can see that here after very long time. And what was the formula for F net, Makesh? mg minus k or mg minus fr or fr minus mg? What did we write?
FG minus FRC.
So this FR can go to the other side, right, Makesh? Therefore, mg will be equal to k into v. Am I correct? Have a look, Makesh. Now, this v will be therefore given as mg by k. This mg by k, we have already derived it initially also. Did you do it? Do you remember this? We just derived this. Can you see this, Makesh? Yahan pe?
Yes, sir.
Okay. I think there is a network issue. It will just get resolved in 2 minutes. So the thing that I am trying to arrive at is that whenever resistive forces act on the system such that resistive forces depend on velocity, ऐसे cases में system attains a constant velocity after a very very long time, और इसी velocity को we call as terminal velocity. I repeat, whenever resistive forces act on a system which are dependent on velocity, इस तरह से the way we have seen here for a raindrop which is coming from the sky on the ground, ऐसे cases में the systems attain a constant velocity. The systems attain a constant velocity which is called as terminal velocity. So we found this terminal velocity from 2 places in this question. One is over here from the direct formula that we derived by integrating, okay, which was the long method. Abhi integration, entire thing, see, so much you did, so much, so long steps. See here everybody, you did the integration, you calculated the expression, then you integrated, got the value for v, and then after getting the value of v at t is equal to infinity, when you substitute t is equal to infinity in this question, then you will get mg by k. So fundamental is either you go the very long way to get the same value mg by k or the largest value for velocity which this system will attain. ये एक तरीका. Second method or the easier way is that since you know that after a very long time this system is attaining a constant velocity, that means acceleration is becoming 0. Directly you take that these 2 forces are becoming equal because net acceleration 0 means net force 0. So net upward force is equal to net downward force, or kv is equal to mg. From here you get the same value in a very short period of time. This is called as terminal velocity. Write this everybody into your copies. This is called as terminal velocity. Terminal velocity. Okay. Write this into your copy. इसको लिखोगे everybody. This is terminal velocity, which is the constant velocity attained by the body. Constant velocity attained by the body after a very long period of time. Attained by the body. By the body after a very long period of time. Very long time. Or after very large period of time, after long time, ठीक है? When net forces on the body become 0, when net forces on the body become 0, when body attains an equilibrium, when body, इसी को we can say equilibrium also. So when body attains state of equilibrium, when bodies attain, मैं 2 बार लिख दिया body, right? Twice. Okay, I'll repeat. I'll leave the next term. So when body attains equilibrium, everybody will put this into your copy, ठीक है? तो थोड़ी समय के बाद what happens when there are 2 forces such that one force is dependent on velocity, ये phenomena हमेशा देखा जाता है. This phenomena is always seen. So in the coming class we'll discuss more about surface tension, Stokes law, etc. But this derivation and all of these formulas were very very important in order to make you all understand कि कैसे exponential curves are plotted, how are we able to calculate the velocity value whenever such exams, जैसे this question is from JEE Advanced, JEE Mains, है ना, as well as you can find this in the coming year NEET का papers. Such kind of questions are very much asked from the learners ताकि ये देख सके are they able to tackle exponential वाला graphs, exponential वाला question. Sometimes graph will be asked. They'll directly ask you the graph, give you the condition and they'll ask you the graph. ठीक है, इसी में you can also calculate acceleration. You can differentiate this to get the acceleration in terms of e. ठीक है, so there are different ways, ठीक है, to get to the final answer, and different kinds of answers can be calculated. But this was something I wanted to like you all to understand. कितने लोगों को समझ में आ गया? How many of you are clear? जल्दी से raise your hands quickly. So I think Aanchal must have joined via YouTube. कितने लोगों को समझा? Everybody, let me know how many of you are clear. Yes. Over to you, dear learners. Yes. Can you all bring your hands down? Yes, if this is clear. Everybody? ठीक है. So you all have your dinner and let's connect back at 9:30 and continue. ठीक है. If there is any doubt, you all can ask me on today's class. If this is clear, let's connect back at 9:30 and we'll continue. Take care. Bye everyone. Okay. So for those who are watching us via YouTube, ये सेशन था आज इन बच्चों के साथ जहाँ पे हमने डिस्कस किया where we discussed like I discussed along with them concepts from fluids where we saw कि how does resistive forces act on a body such that its velocity becomes terminal or final velocity becomes constant or terminal velocity is constant. We also saw some revision from the last class questions based on Torricelli's theorem. In the coming class, we are going to learn more about Stokes' law, है ना? More concepts in terminal velocity, and then we are going to derive real terminal velocity expression, which we have not seen right now. We'll derive more expressions from it in the coming class, and we are going to touch upon the concepts of surface tension. ठीक है? So thank you everybody for being so kind, for being so amazing. Let's catch up at 9:30 and continue with this journey. Bye bye. हमेशा क्लास के एंड में I forgot this. I generally discuss with you all something amazing and important. Amazing concept is that whenever you all have any queries, any doubts with your educators, निश्चिंत होके पूछो. Please be relaxed and ask them. This is one thing. अच्छा, second important thing, if you all would like to be a part of these classes, आप मेरे साथ आकर पढ़ना चाहते हैं, you want to be in these Zoom sessions. These Zoom sessions are paid and the monthly fee is only rupees 3,300. Right now a discount is going on, according to which the fee has been reduced to rupees 3,000 only per month, right? So you can contact me if you would like to be a part of these classes. Thank you everybody. अपने आप को बेहतर बनाते रहना. Let's keep working